Hey, what's up guys? It's Evan, and today I'm going to be showing you this really cool, I don't know about really cool, but like I put together the snake clone. I think it's cool. I'm going to be walking through the code today and just showing you guys kind of like how it works, then link you to the code so that you don't have to continue watching the video. The link to all this code will be in the description down below. Let me know if you guys want to see like a written tutorial. I'm going to go ahead and explain this a little bit, but basically what's going on is we have a, this is a Pixie.js application running on top of a GL context, which is being hosted inside of a React Native app. And what that means is that it's all JavaScript, and you could take the game and put it in the browser, or you could play it on your phone, or wherever you want, because you can do JavaScript just about anywhere anymore. Yeah, I'm like so good at my own games. Oh, dang. And then, you know, if you tap the screen, it resets. There we go. And then you just like swipe around to move. As you can see, the candy hasn't spawned up yet, or the red dot really. I don't know why. So today I'm just going to be walking you through the code. I'm not actually going to write any code just because people have asked for more complex tutorials, and I think this is a better way to cover more complex topics faster. I do like that you guys ask for more complex tutorials, and then my response is how to make Snake the easiest game ever, but maybe we'll find some learning. So what we got going on here is this is all just an Expo init project, right? It's very simple. We're not actually using any of the assets. We just have app.js, we have our game.js, and then our gesture view, right? So that's two React Native components, and then everything else is a game. I'm going to step through the code here real quick. Maybe move the font down a little bit. I'm not going to have time to get into all of what's going on here in the gesture view. This is kind of a drop-in component. I use this in a lot of my games. I use this in Crossy Road. I'll explain really quickly what's going on here. You see we have the Expo, we have gesture handler that we're importing from Expo, and that's React Native gesture handler. And then we're using animated from React Native. And if you scroll way down here to the render function, you see we have a tap gesture handler and then a pan gesture handler. So this is providing us with tap information and then pan and swipe information. And again, this is a very generic component. You could wrap anything in it and it just returns those values for you. Probably not the most efficient way to do it. But when I put it together, I was probably smarter about it. I'll explain really quickly how we're tracking the gestures, because it's a little circulative. It's not very simple. But you see here we're using an animated event, and we have the native driver turned off because we're using a JS listener. So we can track an actual value. I don't know if we're actually even using that value, but high quality content. We have this listener which gives us like that native event from the pan gesture, and then we try to track the axes. Now at this point, to activate the pan gesture, it has like a minimum threshold, so we already know that we've moved enough to determine if we're like going in a particular axes. The reason we do this, and this is important because like Android only recently, and by recently I mean within the last 5 years, started doing this, but iOS, you see you like move vertically, you move horizontally, but then if I start like moving around in any other direction, it's like locked to that dimension. So that just means that it like feels a lot better than if it was moving around like after we had already started our initial like gestural intent. And then after that, we're just tracking the delta movement between frames. Pass that through like an on-pan function that we call back. But again, let me know if you guys want to like learn more about the gesture handler, because this is not very helpful. What we really want to cover is the game. So I'm just going to show you guys very quickly, again, something that's not the game, and that is how minimal the React Native part is. So if we come over here, you see we have just a very generic view, and that view is wrapping the gesture view, which wraps the GL view. So the gesture view, again, like tracks the gestures. We have the GL view, which produces the web GL context that we're using to create the Pixie application. And then over here, we just have a basic text element that we're using to render the score over here. You see here at the top of the function, we have a state, which just has a basic score value. So when we update that through this callback that we put in here, then it will update the UI accordingly. And it won't update the GL view again, just because React Native is very smart about that. So it works really well, and the score works just very efficiently. For instance, if you wanted to put that on like some callback that was just updating all the time, it would still like run and everything would still work, but possibly a little slower. So anyways, this is all that's going on with React Native, and then some like useless styles down here. Everything gets passed through this GL view and then to this game function that we created. So if we hop in here, see everything here is not too much code, a little under 300 lines, but now we can make it like a little closer to not 300. But everything is all JS, so you could pick this up. Again, you could use it anywhere. It's all like stripped and completely away from React Native, which I think is kind of cool just because it's its own thing. Going through it really quickly, you see we're using Expo Pixie, and then this is just a regular version of Pixie, but we do some things to make sure that it uses a constant Pixie instance across, you know, all your different files, just because it's a node project and we want to make sure that that stays the same if we were to like add some extension onto it. And then Expo Pixie just has some tools for making it work inside of React Native, it being Pixie.js. And if you're not familiar with Pixie.js, I should have explained this in the beginning. So Pixie.js is a super fast HTML5 and WebGL renderer. It uses Canvas as a fallback, but Canvas isn't supported in React Native, so we mostly just use WebGL. We entirely use WebGL. And it was built to normalize that WebGL Canvas API system on the browser, and it implements a very simple scene graph API, which is that child-parent relationship, as opposed to the Canvas where you just draw things to the screen. Here you can manage things in a more object-oriented way, and it has a few similarities to the Flash API, but I wouldn't say it's based on the Flash API. It's been around for a while, it's free, it's totally open source, and it's really awesome. The people who made Pixie.js have done an extremely good job on it, so I'm really excited that we get to use it in React Native to make native apps. I would use Phaser.js, which is like the go-to web framework for making games, but it doesn't work on Android, so we're just using Pixie for now. And I'll get Phaser working someday, I promise. So if we come over here, you see we have some settings. You guys can go ahead and mess with these. You can change the size of the snake, like its initial size. You can also change the color of the snake and the food. Let me point at the right ones. The food, the snake, and then the background. To get these colors, all I did was I came over here and I sampled this button right here. So just go ahead and push some keystroke and then click on it. And then you'll also get the background color from that. And it's my obligatory terrible thing to say. So over here you see our default class is this main class, and we're just passing the context. Then we create a generic Expo Pixie application, and if we were to like inspect what's going on here, we're just creating like a Pixie application here. So there's nothing very special going on. You see we shim out some values over here, and then we do a little bit of stuff with the width, the height, and the resolution to match the phone, because on the computer, like window pixel ratio is going to be like close to 1 most of the time. And then over here we have like we're using just a ticker and calling context.endFrameEXP, and what that does is it from what I understand at least, it flushes like all of the GL calls and then pushes them to native. So we just call that every frame. Probably not the most efficient way to do it, but it's consistent and then kind of works. So over here you see we pass in some extra props. We pass in the background color. Not very important, doesn't matter. We have the settings. Oh man, I want to push the font down a little bit more. I hope that's not too bad. You see we have we're measuring the size of the board, just the width and the height. We pass it through to this board function and then this position. Now a lot of the time when people like teach how to make Snake, they use it as an opportunity to teach about like 2D arrays and stuff, which I definitely still use, but they don't really get into object-oriented stuff a lot of the time. But I like object-oriented stuff, so that's how I did it. A big example of this is when you're doing stuff with 2D arrays, you use like the row and column system as opposed to like X and Y. So I've created this class which just has call and row, which stands for column, and then just some like generic constructor, an ability to create a random position like within that, you know, size, and then the ability to add 2 of them together. And you'll see all these functions come in handy later, but that's just this generic position function that we use. And then over here we have a board, and the board is where like all the magic really happens. It manages the snake, the food, and that's about all the magic. We take the board, which extends a Pixie container, and then we just add it to our Pixie stage so we can add the child, right? Very simple. And then we save the board for whatever reason, I can't remember why. So in our constructor, you see we have the size, which is, I think it's just the general tile size. And then we have our board size, which is a position and a time interval. So you could speed this up. I don't know why this isn't in settings. It should be. I know I promised not to code, but I'm bad at coding. Okay, so now that makes more sense. We have our time interval here. If you were to make that, I think, a lower number, then it speeds up the tick process. It's in milliseconds. And if we come over here, you see we're just saving all of these variables off. We're going to use them later. And then we have some generic like restart function, which we can call after a game over. So we have a generate field, and what that does is it just creates the board. And we can look at that real quick. If we take, so matrix is that board, essentially it's the 2D array. And you see we're iterating column through the board size.column, and then we create our second dimension array, which if you guys aren't familiar, a 2D array, it's kind of like you just have a bunch of arrays inside of an array, and then you fill those all with numbers or values or something. So that's what we're doing here by making 2 consecutive for loops. And inside of each one of these, we're creating a tile class, which I know is another class. I also don't know why I have it done in this like weird ES prior to 5 value. Prior to 5 is the new way to say 4, by the way. So if we take our tile size, our column, and our row, and then just some arbitrary other things, we're passing them through the tile, and that represents each square in the board. I'm gonna give that a new direction because I assume most people are just watching the snake move up and down. I was gonna like make it longer, but I can't. Well, yeah, okay. There we go, got one. And then we just add it to child. Again, this extends Pixie container, which is like a generic, you know, high level object. Container is an odd name for object, but we can call this parent function called add child. All these tiles extend Pixie.sprite. Well, actually they extend square, and that extends, okay, so I was completely wrong. But they extend something which can be drawn. And at this point, I guess this is a good time to explain the tile class. Our tile class extends square, and the square just directly like relates to drawing. So a graphic in Pixie.js is like some arbitrary shape versus a sprite, which would have like an image or something. I didn't want to like import any textures or sprites, so I'm just drawing straight graphics. And so this is just a very generic, like we pass in a size, and then we pass in a color, and then we have a begin, like if you're familiar with open processing or even the canvas, like is very similar to that. We set our line style, and again, this maps to the has grid value in settings. So if we were to turn that on, we could see the lines being drawn as well. And so that'll like either map to this grayish color or to this dot color, which is the color of whatever square we pass in. And then we have these in setters. The reason we do that is because if I like say set the color to a different color, then I want to call clear and then redraw with the new color and the new size. And then we have again here, so it's just a very consistent loop of like redrawing whenever values change. So these setters, the ES, I don't even know, something after 4, those make it very convenient to just make those calls whenever we change values. And then our tile will extend this square, and we're just going to add a couple of other things to it, like a direction. And the direction, again, it like denotes which way the snake is moving. And then we have some is food value, or is snack, or is treat. It could be whatever kind of edible you want. We have an update color value. This is kind of similar to like the redraw, where we have a bunch of setters and getters. And if we set it is food, then we're going to change the colors accordingly. So if it's food, we're going to use the food color. If it's active, we're going to use the snake color. And then if anything else, if it's anything else, we're going to use the background color. And then again, a very generic constructor. We're just saving off some values. We don't actually pass in like the correct X and Y's. We just pass in some value, and then we multiply it by the tile size so that each thing comes into the right position. And then is active. And if it's active, what active means is it's like on, so it's part of the snake. I guess is snake would be a better name for that, but that's your guys' weekly exercise. Change that variable for me, and then PR it. I could do it right now with like Command-Shift-L, but I'm not going to. Man, this is a riveting tutorial. Lots of
education.
So that's generate field and a long sidetrack. And now we're going to generate the starting position for our snake back in the restart function, by the way. Oh man. Then over here, we're going to get the snake length. And the reason we save the settings value to a local value inside this class is because the snake length, obviously, it grows over time. Like when we get snacks, now the snake length is like +1 extra size. So we're going to copy this when we restart. And then we're going to say where our head initial position is. Initially, I had this like at some random value, but it was breaking and stuff, so now it's not doing that. Now we just started off at position 3, 3, so it starts right here where's the head. And then for the tail, you see we're setting the same row for the head, but then for the column, we're adding the snake length and then subtracting 1. And then we're using this loop value function, and I can explain that in a little bit. But basically, if you've seen any example of a snake game online, this is why mine is superior, by the way. If you see a snake game, a lot of them, like, they die when they hit the wall, which is, like, the most infuriating, laziest, like, way to program snake. It's cool when you, like, circles through the walls, right? Like, that's the fun way to do it. So I'm using this loop value function, and what the loop value does is it says if it's lower than a minimum value, put it to the maximum value. And then if it's greater than the maximum value, put it to the minimum value. Otherwise, return the value that came in initially. And we use this everywhere. So you could technically still run that whole like wall death algorithm and then just disable the loop value function and just only have it return v. And then you could hit the walls and die. An example of this is like are walls deadly is true. And then if settings.arewallsDeadly, and then we're going to move these two in here and then say not. I guess we should say something nicer like are walls looping. And then we can get rid of the not and do that. So now, like if we were to turn this off, it would just return the value and it wouldn't loop the values. So eventually we would hit a wall and die, except we're not checking for that, so nothing is going to call it. To do that, you would check for like if the position is less than 0 or if it's greater than the max, but nah. Anyways, back over here, I get so sidetracked. So we loop the value. Anyways, we set the head value and the tail value. Now what the head value is, if we click on this, actually I think we just save it, it's just the position. But the reason we do that is because when we manage the head and the tail, then we can change those accordingly and then change the size, but we don't need to manage every other piece in between because every piece is really just a history of the head or a history of the tail that hasn't been updated yet. So we're trying to be really efficient with it and manage like as few things as possible. Anyways, so after we get the head and the tail defined, we're going to loop through the snake length and we're just going to add all the other pieces in between. You see we're still using the loop value. It's just like safe to do it whenever you assign a value to the board, just because like say we start over here, then we want to like check each value if it's looped so that we can go off the side of the screen. But to do that, we're just taking head column and adding I from our iterator, and then we subtract 1 arbitrarily from here. Oh right, for the max value. I'm learning about this with you guys. And we just say that that part is active. So again, we're looking at our 2D matrix. We get our column, we get our row, and then this denotes a tile class, which we say is active. And remember, when we do is active, that goes to a setter. And once we hit that setter, then it updates the color to our snake color. I hope that makes sense. I really do. And then we call restart food. Now, what restart food does is this goes ahead and it clears out all the available food positions. And then we go and we iterate through every child. We iterate through every possible like position and we see if it's active, like if the snake exists there. And if it's not, then we're going to save that position as a possible food position. What we're doing here again, just to summarize, we clear out our food positions, and then we save each one that's available, and then we call generate food. We can call this whenever we want to add a new piece of food to the board. So for instance, if we said generate food twice, then we could generate 2 or 3 pieces of food at a time. So now we've got 3 foods. Pretty neat, I think. You could probably also add that to settings, which is just like how many foods are generated at a time. Let's go ahead and leave it like that, and then clear those out. I guess I could leave them in case we make more changes, which I will probably do. When we call generate food, what we're doing is we go to those food positions and we just select one out of the array at random. You see I just do everything all in one big line, but we get a random number, which is a random between 0 and 1, and we multiply that by the total amount of items in the array, which will produce a random food position, which we can then use to pick a cell out that's empty, and we can turn active on, and we can also turn food on. I could probably put active inside of food, probably makes sense, but that's my coding style. Just now we're done with all those, and we're getting pretty close to being done with the tutorial, I hope. Just for you guys' sake, I can keep going all day. We have the head direction. Now this is whichever direction he's like starting to move, or it or her, whatever the snake is, this is the direction that they're starting to move in. We set it to left. For the directions, instead of defining our own, I'm just using from gesture handler directly so that we get to repeat those values. We don't have some weird like string map that's converting gesture left to arbitrary game left, which I think is a little neat way to reuse those. Then we have is changing direction. Is changing direction is a value that we'll get into later, but basically every tick, if we say is changing direction, that will prevent it from killing itself by hitting the tail. A very dark value, this is changing direction. It's the Prozac of this application, truly. And then we have is running, which is like if the game is stopped, like because you've died, or if it's running. So once we've restarted, we're going to say is running is true. You also have to remember that a lot of these values are like fully resettable. So we call this like not generic, but we call this function every time like the game ends or starts. So it's why it's like a little confusing that we're calling some of these in the first turn, but just remember that we're doing this so that we can like repeat it later, and it just we're cutting down on the amount of code that we're using. Anyways, then we're going to call our interval animation with the time interval that we specified earlier. So when we call interval animation, think of this just as like our tick function. I don't even know why I called it that. I think that renamed it. Command-Shift-L, pro tip. No, that didn't do it. Okay, now it's just called the tick. We're gonna pass in this interval, and then we're just using the generic like window call set interval, which means that every amount of however long it's going to repeat. We're gonna save a reference to this so we can kill it later once we die. We want to do that so that we don't create a memory leak. But then this is like where the magic really happens. This is kind of all the core game logic. This is like the part where in the beginning of the video I'll put a link so that you can jump to the important part. This is that. And you see it's very small. This video did not maybe be this long. But we have positions.food, right? So what we're doing is we are going and saying whatever the current head is, that can't be a position for food. Very simple, right? So we're just making sure that once we update, we remove that as like a possible food position, just because we want to keep that like array fresh so that when we generate food the next time, we're totally safe. And then we have this thing velocity, which is a weird thing to say in like a pixel based animation. But what velocity is we give it the direction, and then it maps the direction. Like if it's up, and this could be a switch statement. If it's up, then position.row minus minus or plus plus. And then we just create a position that has like some, like for instance, say we're going up, the position that's returned is row -1, column 0. And with that, man, where was I just now? With that, like we create velocity, and then we take our head, which is also a position, and we use that add function from earlier to add the new velocity to our current head. And what that will do is move it to the next position, which you're watching on YouTube/exposition. It'll move it to the next position, And then what we're going to do is take and just loop that value. So for instance, say we were here and we moved left a little bit, then we're taking and moving that value so that we can move it over here. Just always safe to do that. Okay, so like after we've looped the position, the next important thing that we need to do is now we've like moved to a new position. So now we need to determine, are we like safe, or have we eaten something, or are we dead? Basically like what you do in real life. Bad delivery. But say we do current head, we want to see if that new value is active. If it is active, then we're going to check to see if it's a food. If it is a food, then we're going to increment our snake length, and we're going to set that is food value to false. Remember, it's still active, but now it's not food. And then we're going to generate a new piece of food to compensate for the fact that we just got rid of a piece of food or a treat or whatever, I don't know. And then we're going to use that onScore method that we define over in the top level in the poorest way possible. Which just sets the state of our upper level UI. And we're going to set that to the snake.length minus the initial size. The reason we do that is that say like our initial size is 10, then we increment by 1. We don't want to go from 0 to 11. I mean, I could just show you guys, but I think you guys get the general idea. Like it starts at snake length, whatever. It starts at 0, right? And then we update. So we don't want to compensate for that. We just want to count the amount of treats that we've eaten as the score. All right, so now you see if we were to get a piece, which, okay, it goes from 0 to 7. We don't want that, so we subtract the settings.size when we update the score. Initial size, boom. All right, so if the new thing is active, right, what this means is that it's either a food or it's also the snake. So when we're in here, we see if it's food, and if it's not food, then that means we've hit the snake and we're dead. But there is a chance that, like, say we're changing direction, in that case, it will still be snake, but we'll also be on it at the same time. So that's why we set this is changing direction value whenever we swipe, so that for that tick, we can move over the position, and then we don't, like, hit ourself at the same time. So it just kind of like it says, okay, now we've moved, so skip this tick, like don't check to see if we've died yet, which could be problematic if there are the walls, which now reveals my true motive for why I have the looping walls. Granted, it's not too hard to fix if you do have the death walls, but my prior statement kind of holds true, but not really. It's just laziness. So if we do hit ourselves, then we're going to call game over. Game over, very simple. We say is running is false, and then we clear that interval that we made earlier, this interval, basically meaning don't do any more ticks, and then we're dead. And then once we're dead, we can check our on taps. So if we get a tap gesture and it's not running, then it means that we are okay to restart the game. Very simple stuff for restarting, and that means we're so close to being done. Now, all we're seeing is if we've moved to a new position and it's not active, then that means it was just an empty square. So what we can do now is update the tail and then say current head is active, right? Very simple stuff. I think we do, no, we don't do current head is active anywhere else. So if we find like a new position, I'll probably slow this video down. No, I won't, it's too hard. But say like I slow this video down and you see like when we move to the new position, we want to just call that current head, and then we turn off the tail, which we'll get to in a second. But we call update tail only in this part and not like in an outer scope, because that update tail function is important for making the character grow. So for instance, say we have update tail just out at this number, then that means that if we hit food, for instance, we're still going to update and move the back of the tail. So we move this up into here, which denotes that whenever we just have a normal movement, we're going to move the tail with us as well. And now let's look in the update tail. I think that's the last function. It's an odd function to be the last one, but it's the last one. What we're doing here is we're saying whatever the current tail position is, turn that one off, right? Example, right? I'll just cut that part out. And then for the food positions, we want to push that part because now it's not active. We could probably have some function which is just arbitrary, and we pass in a, we pass in a piece, we pass in a position, and then it just adds that position to the food positions. I didn't do that, but again, that's another way that you can improve. For instance, say you made like Tron with this, and you wanted to like build it out and add so many more features, you want to make all these smaller features like less of a worry and more generic, so that if you like add a third snake or something, or I don't know how you go right to third, but say you wanted to go from 1 to 3 snakes, then you want to cut down on these basic operations so that they're much simpler. And that's why we make things object-oriented. And then finally, what we're going to do is what we did with the head. Basically, we're doing all the same stuff for the tail we did with the head, another place for a generic function. And I just like using the word generic tonight. But if we were to get the velocity from that current tail.direction, we can add it to the tail. And then again, last thing we need to do, just make sure that we've looped that position. And that's it, I think. That's all we got. Here's the onSwipe function. Just say like if the game is running, we want to check to make sure that direction is defined, just a safety check. And then, oh right, this one is actually important. So we're going to get the head direction and make sure that it's not equal to the other direction. So other direction maps to this, and basically you see I have down is assigned up, right is assigned left, up is assigned down, basically just opposites. So for instance, say we're moving in this direction right and I swipe to the left, which is what I'm doing on screen now, or not, I don't know. Say we do that, we want to make sure that it's not the opposite direction because that's not a valid move. Any other direction is totally fine except for the opposite one, because you might do that by accident when you're swiping. Also, it's just an illegal move. Anyways, after we do that, we say is changing direction is true to do that whole safety check from earlier. And then we set our new head direction, which we use to, you got it. Current head is a getter. Current tail is also a getter. Just getting positions from that 2D matrix. Again, I really hate 2D arrays just because they're, as a visual learner, which I imagine you are because you're watching a video of a weirdo explain snake, like it's just hard to wrap your mind around how a 2D array works, even though it's really not. Just hard to wrap my mind around because it's like for me a 2D array is just like this, and it's not like a grid of numbers. And I don't know. So I like to just make sure that you don't like you see matrix just as little as possible, and you put it in these very easy to understand things like current head and current tail, or at least it's easier for me. Maybe it's really confusing for you. I don't know. I'm gonna make another setting right here. Which is just like the initial food. Because I kind of like that idea of having more than one piece of food on the thing at a time. Then add that over here. Always look for places to add settings to your game just because it like makes it, I don't know, games are hard to make because you get really bored of them quickly. I mean, obviously you would never ever get bored of the game Snake. It's timeless truly, but like when you have settings, it means that you can go back through and just make it more fun or think of like new things to do. So I just always recommend adding settings to your game wherever you can. And I think that is about it for this one, guys. Nothing else. Gonna save it, reload it. Remember the color is subscribe red and the snake is follow me on Twitter blue. Thanks so much for watching, guys. I really appreciate it. If you like this video, do the thing. And if you didn't like this video, also do the up thing. Let me know if this needs more explanation. I could do like a live stream or just write the code from scratch. I hope that this was thorough enough. I said it would be advanced at the beginning, but I made it beginner. If you guys like this format, let me know, and I'll just kind of keep skimming back until we can cover more and more advanced topics, because I like the idea of covering a full thing in one video. Yeah, that's it. Thanks so much for watching. I'll see you in the next video.